This video is on arithmetic sequences. So looking at what we have, arithmetic sequence, the definition of it is going to be adding a constant value Okay, this constant value is going to be known as the common difference. To get the next term. Okay, so we're adding a constant value, so we have to add the same number every single time to get the next number. So our first two examples, determine whether each sequence is arithmetic. If so, find the common difference and the next three terms. So it says find D. We let the common difference be represented by D. So common difference and D are the exact same thing. So first we take our second term minus our first term. So 2 minus a negative 3. Two negatives make a positive, so we get a common difference of 5. But that's not enough to tell us if it's arithmetic. It has to be a continuous pattern of adding 5. So I'm also going to check the third term minus the second term. When doing this, the terms have to be right beside each other. Okay, so they have to be one right after the other. So A3 would be 7 minus 2. 7 minus 2 is 5. I got the same common difference for both terms. So yes, this is arithmetic. So our common difference is 5. That's what we got when we subtracted the two previous terms. And the next three terms. So what I'm going to do is I'm going to take 17 and I'm going to add 5 to it. 17 plus 5 is 22. Then I take 22 and I add 5. I get 27. And then I take 32 and I add 5, or 27 and I add 5 and I get 32. So this answered all three parts. Looking at example 2, we have a new sequence, -4, -12, -24, -40, -60. Again, we need to find to see if there is a common difference. So I like to take the second term minus the first term. -12 minus a -4. Again, two negatives make a positive. When I subtract those, I get -8. Oops, sorry. Okay, then I take the third term and I subtract the second term. So I have -24 minus a -12. Again, two negatives make a positive. It turns into a -12. So if I see these two numbers are different, so this is not arithmetic. And that would be my answer for this one. Next, these two right here are super important. Okay, we are going to use this a lot. Recursive and explicit formula. Explicit formula is the most used formula. So the explicit formula is a sub n equals a sub 1 plus the common difference times n minus 1, where a sub 1 is the first term. D is the common difference, as I said. And n is the term number. So like the 20th term, we would put 20. The 35th term, we would put 35. The recursive formula is a sub n equals a sub n minus 1 plus d, where a sub n minus 1 is the previous term. So if I want to find the 10th term, I have to know the 9th term and add d to it, which again is a common difference. So we have two examples where we're going to write the explicit in recursive formula. So I have 32, 25, 18, 11, and 4. If I needed to subtract them, I would take 25 minus 32. I see I get a negative 7. So my first term is 32. My second term, or not my second term, my common difference is a negative 7. So my explicit formula, a sub n equals the first term minus the common difference times n minus 1. This could also be simplified. So off to the side, I'm going to simplify it by distributing that negative 7. So what that would look like, negative 7 times n, get a negative 7n, negative 7 times 1, I get a negative, or positive 7, two negatives make a positive. I combine like terms, I get negative 7n plus 39. So you could see it written this way for the explicit formula. So I'm going to write that above. Either one is accepted. So negative 7n plus 39, either one. The one I just wrote is in slope-intercept form, where negative 7 is my slope, 39 is my y-intercept, or my zero term. So I start with my first term. It would be the term before this. That would be my zero term, which is 39. So that's kind of a shortcut on how to find it. So there is that. Recursive formula. Don't forget about that. So a sub n equals a sub n minus 1 minus the common difference. Done. That's it. No other way to rewrite that. Looking at the next one, we have 1/2, 3/4, 1, and 5/4. So this might be easier if we get common denominators. So this would be 2/4, 3/4, 4/4 is 1, and 5/4. So my first term, we have to use what they gave us. So a sub 1 equals 1/2. My common difference is going to be 1/4, or 0.25. That's not a 4, sorry. If you do decimals, 0.25, I would prefer fractions, but again, whatever makes more sense to you. So the explicit would be a sub n equals the first term, 1/2, plus the common difference times n minus 1. I keep writing 1/2 twice. That should be a 4 right there. Okay, the recursive formula, a sub n equals a sub n minus 1 plus 1/4. Again, that explicit formula, we could simplify. It would, once we distribute that 1/4, it would simplify to a sub n equals 1/4 n plus 1/4. So that is the same thing, just another way to rewrite it. Looking at this bottom one, it says, so 2 more examples, finding the nth term of the arithmetic sequence. What you need to know is we're going to use that explicit formula, a sub n equals a sub 1 plus d times n minus 1, to find whatever term it's asking for. So my first term, a sub 1, is 32. My difference was negative 7. It's the same example as above. Okay, we want to find the 10th term, so n equals 10. So I just plug and chug. So a sub 10 equals 32 minus 7 times 10 minus 1. 32 minus 7. 10 minus 1 is 9. Order of operations, negative 7 times 9. We get a negative 63. We combine like terms, and we get negative 31. That is our 10th term. Okay, looking at the second one, we want to find the 12th term. Okay, so the 12th term, so a sub 1 equals 9. The difference is a positive 7, n equals 12. Plug and chug, so a sub 12 equals 9 plus 7 times 12 minus 1. 9 plus 7 times 11. That equals 9 plus 77, which gives me 86. Oops, changing colors on me. And that would be our 12th term. So, moving on to the next examples. If at any time you need to pause, please pause. Or if you want to try this and see if you get the same answer before I work it out, please do so. Looking at this, we want to find the missing terms that we're given. Okay, so finding the missing terms. Notice that we are given the first term and the fifth term. So again, we're going to use this formula and adapt it to help us find that common difference. So we know we're going to use a sub 5 because n's going to be 5. We know our first term. We're going to find our common difference, and n is going to be 5, so minus 1. So a sub 5 equals a negative 17 equals 11 plus d times 4. Negative 17 equals 11 plus 4d. Two-step algebra, we want to subtract 11 from both sides. So I'm going to continue the work over here. Okay, we get a negative 28 equals 4d. You divide both sides by 4. d equals negative 7. So I'm going to subtract 7 from each term to get the next one. So negative 11 minus 7, we get 4. 4 minus 7, we get negative 3. Negative 3 minus 7, we get negative 10. And just to make sure, negative 10 minus 7 is negative 17. So that works out. So our common difference was negative 7. Okay, looking at the next example, again, same concept. I know the first and the fifth term. So a sub 5 equals a sub 1 plus d times 5 minus 1. The fifth term is negative 7. The first term is 17. And we have 4 times d. So we just start simplifying. You get 4d here. We need to move over that 17. And continue the work right here. So negative 7 minus 17, that is a negative 24 equals 4d. We divide both sides by 4. Negative 24 divided by 4 is a negative 6. So I'm going to subtract 6 each time. So 17 minus 6 is 11. 11 minus 6 is 5. 5 minus 6 is negative 1. Negative 1 minus 6 is negative 7, so it all works out. Moving on to the next example, we have a lot to do here, 3 different parts. We want to find a sub 6 of the arithmetic sequence, but we're given a 9th term and a 14th term, and we want to write the recursive and explicit equations. Remember, to write the explicit and recursive equations, we have to find the common difference and the first term, and we're not given either one of those. So we're going to use this formula again, but again, we have to adapt it to help us find what we need. Since we don't have 2 of the terms, I'm going to change a sub 1 to a sub 9 because 9 is the first term they give us, which also changes this one to a 9. A sub n, I'm going to let that be the 14th term, which plugs in a 14 right there. So I'm just going to plug in what we know. A sub 14 is 195 equal to the 9th term, which is 120, plus the common difference times 14 minus 9 is 5. You guessed it. So the first step we're going to do is find d. Notice that's the variable we have left. To do so, I'm going to subtract 120 from both sides. That gives me 75 equals 5d. I divide both sides by 5. D equals 15. Now that we know D, we're going to find A sub 1. So let me change colors so they don't all blend together. Okay, we're going to change that 9, that A sub 9 back to A sub 1, which means we're changing this term and this term back to a 1. So we have 195 equals A sub 1, plus we now know our common difference is 15, times 14 minus 1, which is 13. Again, remember I changed those 9s back to 1. So I multiply 15 times 13 is 195. I subtract 195 from both sides. I get A sub 1 equals 0. Okay, one last step, well I guess 2 more steps. Let's go blue. We need to find A sub 6 because that was the whole point of this. So A sub 6 equals our first term, which is 0, plus our common difference times 6 minus 1. Turns out to be 15 times 5, which is just 75. Okay, from here we need to make sure we write the explicit and recursive formula. So the explicit, there's 3 different ways this can be written. A sub n equals 0 plus 15 times n minus 1. It could be A sub n equals 15 times n minus 1, where we leave off the 0. Or it could be A sub n equals 15n minus 15. The recursive, there's only one way to write it. A sub n equals A sub n minus 1 plus 15. So that's everything we needed to find. It is a bit of work. Number 2, I suggest that you try it on your own and then check to see if you did the same thing that I did. I'm following the exact same order of solving. Again, I'm going to use this formula. This is our favorite formula of the day. But instead, I am going to change this to A sub 14, this to A sub 8, which makes this 14 minus 8. So A sub 14 is 157 equal to 85 plus D times 8, 14 minus 8. Is 6, sorry. So I subtract 85 from both sides. When I do that, I don't have a calculator with me. I get 72 equals 6D. I divide both sides by 6. I get D equals 12. Now that I know what D is, I can solve for A sub 1. So I'm going to have A sub 14 equals A sub 1 plus the common difference times 14 minus 1. Again, I'm switching both terms back to 1. So I have 154 equals A sub 1 plus 12 times 13. 154 equals 12 times 13 is 156. Oh, I'm changing numbers. That should be, I'm sorry. These should be 157. There we go. Subtract 156 from both sides. A sub 1 equals 1. Then we need to find the 5th term. A sub 5 equals the first term of 1 plus the common difference of 12 times 5 minus 1. We get 1 plus 12 times 4, 1 plus 48, 49, That's our fifth term. Now we just got to write the formulas. I'm going to write them below it this time. So a sub n equals our first term plus our common difference times n minus 1. Or you could see it written expanded as 12n. That would be a negative 12 plus 1, so minus 11. Over here for the recursive, a sub n equals a sub n minus 1 plus the common difference. So this is all you need to know about arithmetic sequences.